How's everyone doing today? Good, 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 good. So as we go forward, I'll give you a little background on myself. I was a systems engineer for several years for X-ray and CT systems on the medical side. So I have quite a bit of experience with process control and standard operating procedures and such. Um, WENZEL is one of the largest, or is the largest family enterprise in metrology in the world. Uh, they have a 15,500 square meter building manufacturing facility in Germany, in Bavaria. They have a swath of land that their father purchased in the 60s because it was relatively inexpensive at the time, and it's not in an industrial area at all. It's actually the fields you see on each side are protected, and they have to use grazing animals to keep them cut. And there's golden eagles there, and so it's a very beautiful place to visit. The Wenzel factory itself was founded in 1956, in 1968, pardon me. It's family-owned business. It's greater than 500 employees, 17 locations throughout the world. Sales and service and product lines have 5 of them. Over 12,000 machines have been sold since they've been in business. And they spend quite a bit of money on R&D. It's very important. Mr. Wenzel, who started the company, was an engineer himself. He started by manufacturing precise granite. So we're vertically integrated. We manufacture large slabs of granite, which we mine out of South Africa. The granite is specifically formulated for metrology work. It's a gray-black granite. It's not too hard, it's too brittle. It's not too soft, like orange granite, so on and so forth. So they spent a lot of time with the beginning of the machine, which is the granite platform. Our U.S. facility is in Wixom, Michigan. It's about 17,000 square feet. The Wenzel facility holds 16 to 20 machines at a time. We also perform CT scanning services in this facility where we have 3 machines. So technically, the 4 types of machines we offer, these are metrology-grade machines. They have to meet a criteria of the same thing that you would use for a measurement machine, automated measurement machine, CMM. We want to make sure that throughout the whole range of the detector, throughout the whole scan envelope, each measurement is perfectly aligned. So we have a larger machine with about 700 millimeter vertical scan capability, down to the tabletop version, the exact CTS, where you could do about 40 millimeters. As I said, we calibrate each machine using what we call a birthday cake. It is ruby balls on studs that are exactly calibrated. We provide then a certificate for the whole calibration throughout the range of the CT scanner's capabilities. And it's repeatable too. This is very important, especially with metrology devices, that you can run it all day. Make sure you maintain the temperature. The granite provides stability throughout the range, and we're able to repeat our measurements for months. Let's go backwards once. So for medical devices, we offer software that will provide you a way to maintain your records, that the device has been checked, that it passed its test for measurement, that it matches the drawings. So we do a CAD nominal or a CAD actual measurement with the CT system, and actually with all of our measurement devices. It'll give you your routine name, your username, measurement time, supplier, serial number, purchase order number if that's necessary, the features measured, and who inspected it. The thing here is that it should be enough information to match your standard operating procedures for your FDA compliance. And then we provide a report so you can look back for traceability throughout the life of the product. This is our desktop unit. It's 130 kV of penetrating power. It's a very flexible system. It still provides you geometric magnification, but it's, you know, a 500-pound machine that can be put on a desktop in your quality lab or your research lab. You're able to check then your devices that you are manufacturing or testing. This is an example. We used a hearing aid off our physicist there in Germany, and we took a CT scan of this. The CT scans are used on this small device. So far, we've used them for small earbuds to make them ergonomically correct, small flexible parts like seals, like medication dispensing devices. Because you don't have to touch the part, you don't have any distortion to the part. You're able to do a CAD actual comparison to that part with your drawing, with your CAD drawing and data. You could do seals. We've done wear tests on seals where, you know, a customer will get back a bunch of seals and they want to find out where these seals are wearing, how they stand up over time. So we do forensic analysis of a lot of the parts as well with CT scanners. Hose connectors. One of the biggest things we do is fiber optic connectors because they're quite complicated. And they have a lot of internal measurements that require several checks for each one that's made so that they fit with an airtight quality. Airtight, watertight, whatever you have. Plenty of dental implants. We do several dental implants and parts, dental fasteners, bridges, things like that. So as you get larger in your machines, this machine here is our M, which is the next level up. It's a 225 machine, 225 kV penetrating power. It's a little lower resolution. It's 25 microns. However, it's a faster machine. It has a higher current. It's really good for shop floor applications where you have a somewhat untrained or, you know, a untrained person who could just put the part in, press a button and go. It's very easy to use. We try to make our machines so you don't have to have a doctorate in material science to run it. And we try to automate as much as your analysis as possible throughout the scanning. A little bit more in size is our L machine. This one also uses a 225 tube, but we've recently put 180 kV microfocus, so the resolution in this machine can get to 5 microns throughout this whole scan envelope, which is important because you have a larger scan envelope and you can scan many parts at the same time. So this gets into the realm where, sure, you could do larger parts, but also think in the volume of the number of parts you can do with your scanner. The tubes, very long lifetime. Our German engineers have provided these X-ray tubes and detectors so that we're looking at a useful life of up to 10 years. And some of the machines have been installed and working for much longer than that without a tube replacement. Actually, an X-ray tube is kind of like a light bulb. If you think of it that way, it has a filament and it has a bias to it. So as opposed to making light, it makes electrons which bounce off a target and create X-rays. This is our largest machine. It has dual doors. So we could do robotic loads, unloads, pass-fail sort of things. It has the large 700 millimeter scan envelope and 4,000 by 4,000 pixels. This also is at 5 microns resolution. So the X-ray tube itself is a open X-ray tube. Basically, that means that you can take the X-ray tube apart and rebuild it. So if you're running the thing 24 hours a day for 6 months, you can take it apart and make it pretty much like new. You replace the filament physically, you clean the inside, you put a new connectors in it, and the machine runs for life. We have our own software, but we also have an open architecture. So we can use Polyworks, we can use any number of CAD softwares that you may have. A lot of our customers who we do services for, we provide them an STL, and they load it right into their CAD software. The STL then has all the data from the scan, the actual scan data of the parts. It's very good for, PointMaster is very good for reverse engineering. Many of our customers do that. Say, for instance, if you have purchased a company and it has incomplete documentation, you're able to take some of the molds, like extrusion molds, things like that, and gather data using a CT scanner so that you can reverse engineer what they're doing and create CAD drawings on just about whatever they want to continue to build. So as I said, you get your CT scan data, we can convert that to an STL, or we can convert that to other file formats too, such as volume graphics, which is a very popular CT scanning software. PointMaster does the analysis, normal functions, so you could take one part as your normal part, you could compare it to your other parts that you're building if you don't have a CAD drawing or CAD data. And by the way, it's not, we're a metrology-grade system, but we can do non-destructive testing as well. So you can look for voids in the part. You can look for small cracks. You can look for, are the threads positioned correctly on a certain part? Are the, gears aligned with the CAD drawing, with the nominal drawing, or the nominal part that you're X-raying, to make sure that if the gear is keyed, say for instance for high-speed drills for dental devices, you're able to make sure that all the gearing is correct and will fit before you assemble the drill itself. Let me go back with this. We also use Quartus, our own software, which that gets into the very, very detailed GD&T, dimensional accuracy and notations, and you could do multi-part analysis, so we can then automate the process if you're doing, 200, 300 parts at a time in your CT scanner. The Quartus system is very good with geometry, with free form, with curves, reverse engineering. We talked about the STL systems. So a lot of people will use PointMaster and Quartus in conjunction. If they need more, they go to a higher power software, which is our Quartus device. If you go with like a software like Polyworks, it's kind of all self-contained in one system. So part of Quartus has the generator module for automation and evaluation. We're able to take a look at the part, the specific product manufacturer information, PMI, the model-based definition, MBD, and then we're able to tell you exactly what the measurements are for any number of parts. This will provide you with a greatly reduced time of your measuring program generation. Electronic data exchange reduces the transmission errors and saves time by automating the process. So you have your exact CT control. Our designers made sure that the technical, that it matches the technical capabilities of the people using the machine. We provide simple, red is bad, green is good. So when you set up your part, you take an x-ray of it. If it's underexposed, it'll turn blue. If it's overexposed, it turns yellow. So you can adjust it with your kilovoltage and your current into the green area, and it'll tell you what filter to put in the machine. We have an automatic filter wheel, so it's going to select the filter for you. So your engineer that is using the machine doesn't have to, or technician doesn't have to be an X-ray expert and know all the material science that goes along with selecting the right X-ray technique. PointMaster provides you visualization and analysis, defect analysis, wall thickness analysis, all your nominal actual comparisons. We also have worked with several extrusion companies and provide a compensation for shrinkage and warpage. Allows you to design your molds quicker, and it's all automatable. As I said earlier, the Quartus system will provide you your GD&T of form and dimension, calibration of CT systems, multi-part statistics, all your reporting. So the reporting you can manage, which is real important for going back to your FDA. This will be something that you would put in a file with each part, and it'll automatically generate a PDF or an electronic file that will give you the dimensions, the specific dimensions, the critical dimensions, and a heat map to say, is there warpage, where it is, so on and so forth. Is it in tolerance? So this is kind of new. We were involved with gear analysis, and we sold that part of the company, and then we recently bought that part of the company back, and so we have a gear analysis as well for visualization of the analysis, defect analysis, wall thickness. So CT will provide you, are there small cracks? Is there any weakness in the structure? And due to, porosities, nominal actual comparison, and warpage. This is an actual CT scan of a gear. And what's surprising is the gear surface, you can be measured with your CMM, measure it with your calipers, it looks fine until you look inside of it. And there's large groups of porosities. There's things in there that could really hamper the life of that gear. So with your independent CMM machine, you can measure the external dimensions. You can, with your optical machine, you can measure your external dimensions. With the CT machine, you can measure all your internal dimensions and also the quality of the material itself. We then provide software to visualize the tooth profile to make sure the gear is going to mesh perfectly with what it is supposed to mesh with. And we give you a printout of that sort of thing. So you can see with the tactile measurement, it might be off a little bit. So the machine on the far left. And then somewhere in between is the optical measurement. Because there's glare, there's different things that you might have a problem with optical measuring. And then CT kind of gives you exactly what you're looking at, what is there. CT systems, we're looking at a typical variation of 3 microns. So here's the automation. We have a shop floor interface, so we could use it on up to 8 different machines. We could provide you not only interface to your CT machine, but also to your CMMs that you have in stock. We also have ability to go with other manufacturers' CMMs as well. So we use our CT control, which is a part of Point Master, and then Quartus to give you the discrete measurements and interface that to the shop floor interface so that you're able to pull all that together and do several parts at once. So when we talk about your scan volume, this is what we're talking about mostly for smaller parts that you're manufacturing. The automated solution, we have a 150 kV tube, 180 tube, or a 225 tube. So we select the optimum tube size for your part inspection. We then create a pallet, so we can manufacture these pallets for you so that the part, you want to make sure when you're scanning the part that it doesn't move. You don't want a blurry image movement. If you ever go to the doctor and they do an x-ray, they say, breathe in, hold your breath, because they don't want your lungs to move while you're doing a chest x-ray. Same thing with this. We want to make sure that the part doesn't move as you're spinning it on the turntable. So we can stack the turntables then. Each one of these pallets are keyed, so we know where every single part is on the pallet. The pallets can then be set up. The pallets are made from a radiotranslucent material. Basically, it's very close to air. You don't see the pallet artifacts. You would see a piece of Scotch tape much easier than you would see these pallets. So what happens is you can manufacture your pallets in any shape or form, you know. So whatever parts you have, you sit down and figure out how many can you put in there, how many to optimize your procedure, to optimize the time you use and make it more productive. This particular customer was doing 12,000 pieces a month. So you have the stack of pallets on your turntable. The detector is on the right, the X-ray source is on the left. So we can magnify that to a maximum resolution, but yet keep all the parts within the scan envelope. And what you end up with is basically looking at all your parts at once as you CT scan it. So all the processes from beginning to the analysis can be automated for all the parts very quickly. These are some of the case studies we have, and I'll be glad to go over them. These are dental implants, the screws, the pieces, different pieces that you use for that sort of project. So our customer really liked it at NeoLab because they were able to measure several hundred parts at a time and weed out the bad ones very quickly. Our optical scanner, I wanted to mention this because when you get into CT X-ray, doing hip joints, knee joints, it's a very dense material. It's very hard to penetrate it with X-rays. So we use the optical scanner, and currently that's the fastest scanner we have, so that you could view the all your curves, all your shapes, to make sure they're within tolerance. So as I said, WENZEL's been around for a long time. We have several operations throughout Europe, the United States, and Asia. And here's some of our customers. And I want to thank you guys. If you have any questions, we got a few minutes left. I'll be glad to answer them. Or you could come by our booth. We moved our booth to 736. We were at 6 something, and there was an obstruction there, so we moved it over to 736, and we'll be glad to answer any of your questions in detail. I can also scan your badge too and send you information. Any questions? No? So I did a good job? Good, thank you. Cheers.